All right.
Feels like we should be done by now, like 52, so.
Such a big number.
The integral of cosine to the fourth of x minus sine to the fourth of x dx. Cosine of 2x equals cosine squared of x minus sine squared of x.
So I say we take a squared out of the things.
How?
We factor it
Squared. I mean,
Factor it out. So I could think of this as, if I wanted to, cosine squared of x squared minus sine squared of x squared. Right, because squared would be to the fourth.
Don't forget the dx.
True that. It would have come there eventually. So now, if I want to, if it's easier to visualize, I can think about this as like x and y. And x squared minus y squared factors into what?
1. Not 1.
No, definitely not.
Well, it's
The difference of squares.
X plus y.
X minus y.
X minus y.
So I'm going to use that over here and call this the integral of cosine squared of x minus sine squared of x times cosine squared of x plus sine squared of x dx. Now, any suggestions? When I see trig function squared, what is my first thought?
Equals 1. Like,
Well, the one thing.
What is the name of them?
The Pythagorean identities.
Yep, so sine squared plus cosine squared equals 1. So that means that this part right here would become 1. What do I know about this part right here?
That's cosine of 2x.
So this is the integral of the cosine of 2x dx. Now, what is u? You can't say tired today.
I mean, I could.
Mentally absent.
Du is dx. Divide by 2 because I don't have a 2 in there, so 1/2 du equals dx. So now I have the integral, well no, 1/2 times the integral of the cosine of u du. It's the antiderivative of cosine.
Sine.
So 1/2 sine of u plus c, there we go. And then I can rewrite that 1/2 sine of 2x plus c. That wasn't as bad as it could have been. It just looked like it was going to be bad. Make a u substitution and integrate from u of a to u of b.
I kind of zoned out when you said that.
The integral from 0 to 1
Shut up, Booty Man.
of r times the square root of 1 minus r squared dr. Basically, I'm doing the same thing, it's just now a definite integral. So I have to evaluate it. In short, is what's happening. So what is u?
1 minus r squared.
So du is
2r. Wait, negative 2r dr.
Yep. So what do I need to divide by?
-2.
Yep. So this will be negative 1/2 du equals r dr. So now I have the integral, or well, negative 1/2 in front, integral from 0 to 1 of u to the 1/2 du. Antiderivative of u to the 1/2 is
2/3 u to the 3/2 plus c.
So since it's a definite integral, I don't need plus c anymore.
Okay.
Not that like you can't write it, I guess, but it's just going to disappear in the end because we have a definite integral. So now this is going to be negative 1/3. I'm going to go ahead and replace u here so I don't have to write it again. 1 minus r squared raised to the 3/2 evaluated from 0 to 1. So I'm going to just keep that negative 1/3 out front and then evaluate at 1. So 1 minus 1 squared raised to the 3/2 is
What? Why are you looking at me, Josh?
I don't think
One.
he knows.
0.
Wait.
0.
What did we plug in?
So this is 1 minus 1 squared to the 3/2
Okay.
minus 1 minus 0 squared to the 3/2.
1.
She got that one.
Got that one.
She did get that.
So this ends up being positive 1/3. So not that bad, right?
Debatable.
58. The integral from negative pi to pi of the cosine of x over the square root of 4 plus 3 sine of x dx. Thoughts on what you should be?
Thoughts on where I should be is the where instead of what. You should also be at home.
To be in bed.
Yeah.
I have no idea.
4 plus 3 sine of x.
Because what's the derivative then? 3 cosine x dx. So I want to, even if I, like, let's say I had chosen cosine of x first. Well, when I took the derivative, I knew that still wouldn't help me. And so if I have a radical, especially if it's on the bottom, I definitely want to be thinking probably whatever's inside of it's going to be what I'm replacing. So now, divide by 3. 1/3 du equals the cosine of x dx. So that takes care of the top of my fraction. So I have outside 1/3, the integral from negative pi to pi of, I'm going to go ahead and rewrite this here as like how this would have been the cosine of x times 4 plus 3 sine of x to the negative 1/2. I'm going to go ahead and write it as u to the negative 1/2.
Don't forget the dx.
Well, I am. I was just rewriting this part. I'm not actually, like, rewriting the whole thing because I didn't write the integral. So this will be u to the negative 1/2 du. Antiderivative of u to the negative 1/2.
Negative 2/3 u to the 3/2. Or
Negative.
Add 1.
U to the 1/2.
2u to the 1/2. Is that what you said?
Negative.
Why would it be negative?
Brain.
That's why I had to register. I was like, hold on.
wait, so when we are doing that, like when we replace with u, the cosine of x goes away?
Because the cosine of x is part of du.
Oh.
The derivative of that was 3 cosine x. So since the cosine was there, it's like cosine of x dx. That part just was du.
Okay.
So now this is evaluated. Nope, I'm going to replace first, then I'll evaluate. So 1/3 times 2 square root of 4 plus 3 sine x.
Can we call it 2/3?
Yeah, we can do that if you want.
I do want.
Evaluated from negative pi to pi. So this would be 2/3 times, since this is a lot, I'm gonna write this out. Square root of 4 plus 3 sine of pi minus the square root of 4 plus 3 sine of negative pi. So what is the sine of pi?
-1. Wait.
Sine.
Oh, 0.
So that's 0. What's the sine of negative pi?
0.
So these are both 4 plus 0 under the radical, so that's just the square root, the square root of 4, which is 2. 2 minus 2 is
0.
my paper didn't have the square roots on there, and I don't know why. So I was like looking at it funny, and then I was like, wait, my paper's wrong. Which also means that last year nobody caught my mistake, and they could have earned a cookie point.
What was the mistake? Oh.
I had it written without the radical, so I just wrote them in. Well. I mean, we got the same final answer, but yeah. All right, integral. 0 to pi over 6.
I don't really like it when there's pi.
Cosine to the negative 3, 2 theta, sine 2 theta, d theta. Yikes. Oh, it's not as bad as it looks. Okay. I'm processing
Can we
now.
raise the d theta to the nt?
What?
Raise the d theta to the nt.
No.
Yeah.
All right. Thoughts on what you might be?
Confused.
Sine squared theta?
There's no squared.
Oh, sine 2 theta.
2 theta.
2
Just
theta.
regular 2 theta. Because the two things have the 2 theta.
So what is that going to help me with?
Nothing.
Nothing. What in here is something weird happening to it?
Sine.
The cosine being raised to the negative 3. So perhaps I should think about this as the integral from 0 to pi over 6 of the cosine of 2 theta to the negative 3 times the sine of 2 theta d theta. So now what should you be?
Cosine 2 theta.
Cosine 2 theta.
I was gonna say sine.
What would that make du?
Negative sine. Theta.
else? It's a chain rule. 2.
I didn't realize chain. Got it out.
So I don't have a negative or a 2. So I'm going to divide by that. So negative 1/2 du equals sine 2 theta d theta. So I've got negative 1/2, the integral from 0 to pi over 6, u to the negative 3 du. Antiderivative of u to the negative 3 would be
I'm gonna say negative 1/2 u to the negative 2.
Yep. Oh, I keep trying to evaluate before I plug back in, and I want to plug back in first. So negative 1/2 times, or just appease Josh, positive 1/4
Thank you. Much appreciated.
cosine 2 theta to the negative 2, evaluated from 0 to pi over 6. So perhaps it would be easier to think about this as 1/4 cosine squared of 2 theta, or maybe actually cosine 2 theta squared, evaluated from 0 to pi over 6. Now, I'm going to actually put the 1/4, I know I keep changing, but out front, because then I have to write it twice if I don't. So then I've got 1/, the cosine of 2 times pi over 6 squared minus 1/, the cosine of 2 times 0 squared. So what's the cosine of pi over 3? And that's 1/2 squared. What's the cosine of 0?
1.
So this is just minus 1. What's 1/1/2 squared?
4.
So this is 1/4 times 4 minus 1, or 3/4. We have successfully made it to our final problem of this section. Only 66 problems in.
Oh, joy.
Or the end of Tori's birthday in pi. The integral from 0 to 2 of e to the x dx over 3 plus e to the x. Tricked Josh. Ice cream next period. I'm so excited.
Ice cream? Did someone bring it?
Individual cups, so they're around.
Hey,
Hey. No, I will in like 15, 20 minutes. For Jonathan or for Isaiah? Okay. Okay, I mean, I could also send Tori sitting in my room. She may be willing to go get it for me. Okay, Isaiah told me that he has pizza coming at 1:15, so I'm just letting you know there might be more pizza coming. You know, you know what? You come over next period and you party with us because there's more than enough food in my room. Okay, sounds good. Bye. Would you mind running and picking up a pizza from the office? Thanks.
They ordered pizza?
Yeah, the 8th graders have pizza. They have pizza coming. I have some mini pizzas in the freezer. That was my lunch.
And you're really gonna party hard.
Pizza and ice cream.
Oh.
A little bit scared.
Why?
I know.
They're gonna be wild.
They're already wild. How much worse can it get?
Maybe it'll like calm them down.
Probably not. Unless the sugar crash hits before class is over.
What if it hits like right when class ends?
Well, then that's an RIP because they're going to PE from me. And some of them are at tennis practice.
Oh, like Sammy.
Captain.
Not you two.
All right, what is you? Because I want to be done with this section.
You is done with this section.
Say it one more time.
E to the x? No. 3 plus e to the... Oh, yeah.
Dang
You
it.
scared me.
And du.
Delta.
Well, my GU doesn't change, so it's e to the x dx.
Yep.
I understand why it's like that. Okay.
Wait, so why couldn't it just be e to the x?
Because we need
Because that wouldn't have really solved our problem.
3.
Because this is 3 plus.
Oh.
So yeah, another one that this part of why we did this one, we haven't really had this, but the other thing is if you have a fraction, it's typically going to be what's in the denominator. Because usually live with these problems, the denominator, when you take the derivative of the denominator, is going to give you the numerator. So the integral from 0 to 2 of, I'm going to write this as u to the negative 1. Are we tracking y? I can do that.
Yes.
Okay. Trying to save steps here. And what's the antiderivative of u to the negative 1? Or 1 over u if you want to think about it that way.
1.
ln of u.
ln of u.
Dang it.
Specifically the absolute value of u. So this is then the ln of the absolute value of 3 plus e to the x. Obviously there's no way that can be anything other than positive, so I won't have to keep the absolute value. It's glitching for a second. Evaluated from 0 to 2. It says the ln of 3 plus e to the 2 minus the ln of 3 plus e to the 0. Thanks.
Yep.
Just wherever it'll fit is fine. I need to find Cash and give him his container back now that it's empty.
What did you bring?
He made homemade cookies and put pie symbols on them.
Oh, that's cute. Wow.
All right. You're going to have to use a calculator on this problem, except for because I don't want you to do this part on the calculator. What is e to the 0? 1. So that's going to be the ln of 4. And then you're going to have to type that part in. But we can just do 3 plus e squared because we know that's not going to be anything that's negative. I'll just save you from having to type it in. It's 0.954. We stopped what problem the other day? 49, okay.
For homework, I'm assuming.
Yeah. So then 51, which will be more like what we did with 52. It's a little bit easier than 52. And then for 53 to 65, pick 2 odd. Now, you can obviously do more than that if you are so inclined. I wouldn't just do like 53 and 55. Obviously, I would choose something that are a little bit harder than those. But none of them are like super duper hard. 61, 63, and 65 are all decimals, just as a fair warning.